Assalamu alaikum. Dear viewers, I am Dr. Noshin Afshan and you are watching the lecture of Inorganic Chemistry with the special topic of discussion being valence shell electron pair repulsion theory. Our next system is Ab4 system. When a central atom of a molecule is bonded to 4 other atoms and has no lone pair of electrons on it, the molecular geometry will be tetrahedral, with the bond angle to be 109.28 degree, and it ranges from this value to 109.5 degrees. And the examples under this category are silicon tetrahydride, silicon tetrafluoride, methane, carbon tetrachloride, boron tetrafluoride ion, ammonium ion, sulfate ion, and perchlorate ion. Hence, the structure of methane has been explained here, that the electronic configuration of carbon with the atomic number being 6 is 1s2, 2s2, 2px1, 2py1, and 2pz to be empty at its ground state. And at its excited state, the one electron from this 2s orbital jumps to the 2pz orbital, and in this way, these 2s and 2p orbitals are partially filled. That means this second valence shell, or this second shell acting as a valence shell, has 4 valence electrons. Because one electron resides in the 2s orbital and one electron resides in 2s orbital and 3 electrons reside in 2p orbitals. Hence, these 4 valence electrons in the 4 orbitals pair up or overlap with the 4 hydrogen atoms, or with the 1s orbital of the hydrogen. So, in this way, every hydrogen atom would make up a bond pair with carbon, and it would have no lone pair of electrons. And hence, if we orient all these bond pairs at the maximum distance from one and each other, then the bond angle comes out to be 109.5 degrees. In the Lewis structure, we denote the electrons in the form of dots, and every bond pair has been shown with the help of a pair of dots. And hence, this type of geometry is called as tetrahedral geometry. And hence, the HCH bond angle comes out to be HCH bond angle comes out to be 109.5 degrees. The other examples under these Ab4 systems are silicon trihydride, or silicon tetrahydride, and NH4 plus ion, that is ammonium ion, and their geometry is like a tetrahedron. Then the subcategory of the Ab4 system is Ab2 E System. That means a central atom A has been bonded with 3 bond pairs and has 1 lone pair of electrons. And the value of the bond angle in this case would be lesser than 109.28 degrees, because 1 lone pair over here would repel these bond pairs closer to each other and away from this lone pair of electrons. And hence, in this case, the geometry of the molecule would be trigonal pyramidal. And different examples under this subcategory are ammonia, phosphorus trichloride, phosphine, and arsenic trichloride. Then our next subcategory is Ab2 E2 system, that is also comes under the main system of Ab4 system. And in this case, a central atom A has been bonded with 2 bond pairs and 2 lone pairs of electrons. And since there are 2 lone pairs of electrons, then they would repel the bond pairs even much closer to each other, and the value of the bond angle, these 2 lone pairs of electrons would repel the bond pairs of electrons much closer to each other, rendering the value of the bond angle to be much lesser than 109.28 degrees. Hence, their geometry would be angular or bent. The different examples under this category are water, hydrogen sulfide, sulfur dichloride, N2O, and Cl2O. For example, if we consider the example of the water molecule, then the Lewis structure of the water molecule comes out like this. Here the oxygen atom has 2 lone pairs of electrons. If you see the electronic configuration of oxygen, then it can be seen that the 2s and 2px orbitals contain 2 electrons in each of them, and 2py and 2pz orbitals are partially filled, which make up the 2 bond pairs with 2 hydrogen atoms. And hence the bond angle in the case of water molecule comes out to be 104.5 degrees, and its geometry in the form of tetrahedral or in the form of tetrahedron has been drawn like this, where this is the one corner of the tetrahedron, and here these are the second, third, and fourth corner of the tetrahedron. Our next system is Kb5 system. In this Kb5 system, a central atom is surrounded by 5 bonding electron pairs, and the molecular geometry comes out to be trigonal bipyramidal. Because here these 3 that are represented with Be, these 3 atoms represent that these 3 atoms are at equatorial positions, and this one and this one, these 2 ligands have been attached at the axial position, and hence in this way the central atom retains a triangular that is formed by these equatorial positions, and the bipyramidal that is formed by these 2 axial positions. So in this way its geometry comes out to be trigonal bipyramidal. The number of bond pairs that are 5 and with 0 number of lone pairs around the central atom, and hence in this way the bond pair between the axial positions, that is BA, A and BA, that shows that the ligand at axial position, then A, and the ligand at axial position. So we represent it as the bond angle between axial positions comes out to be 180 degrees, and the bond angle between these 2 equatorial positions, or either this one and this one, these 2 equatorial positions, or even this equatorial position, between any 2 equatorial positions comes out to be 120 degrees, and the bond angle between axial and equatorial positions, or the bond angle between 2 atoms that are at the axial and equatorial position, is the 90 degree. So we may write down that B at axial position, then A, and the B atom at equatorial position. The bond angle between BAB is 90 degree, or the bond angle of axial equatorial position is 90 degree. Hence, the Lewis structure for phosphorus pentafluoride or phosphorus pentachloride or antimony pentachloride shows that there are 5 bonding electron pairs around the central phosphorus atom. And hence, the VSEPR theory predicts the trigonal bipyramidal geometry for all these molecules, because the maximum separation of the 5 bonding electron pairs around the central phosphorus atom is achieved when the 5 fluorine atoms lie at the corners and the phosphorus atom in the center of a trigonal bipyramidal geometry. Hence, their geometries or the geometries or structures of the examples, that is, phosphorus pentafluoride has been shown over here. The Lewis structure has been shown with the help of dots, where the valence electrons of every fluorine atom has been shown in the form of dots, and the bond pairs between fluorine and phosphorus have been shown by putting a small line. And here, these geometries of the phosphorus pentachloride show the values of the bond angles and their alignment. And here, it represents that here these 3 ligands or these 3 fluorine atoms at the equatorial positions make up a triangular shape, that is a trigonal, and these 2 fluorine atoms at the axial positions form a bipyramidal. Hence, in this way, the geometry of this molecule is trigonal bipyramidal. This type of geometry has been retained by the heavier group 5A elements, that are phosphorus, arsenic, and antimony. All these atoms form some covalent compounds by sharing all of their 5 valence electrons with 5 other atoms. So, our next system is Ab4e system, where a central atom of a molecule is surrounded by 4 bonding electron pairs and by 1 lone pair of electrons. Hence, the molecular geometry is seesaw. And this geometry is also irregular tetrahedron. And for example, sulfur tetrafluoride, tellurium tetrachloride, and iodine tetrabromide. Since if we take the example of sulfur tetrafluoride, then in this case, the sulfur has 5 electron pairs around it, 4 from sulfur-fluorine bonds and 1 from the non-bonding pair. The non-bonding pair has been shown here in the form of a pair of dots in the case of Lewis structure, and the bond pairs sulfur-phosphorus, sulfur-fluorine bond pairs have been shown in the form of these short lines. The 5 electron pairs about the sulfur atom should have a trigonal bipyramidal arrangement, because the axial and equatorial positions of the electron pair are not equivalent, so it has been decided that in which of these positions the lone pair would appear. Hence, it is experimentally observed that the lone pair of electrons would occupy an equatorial position and the 4 bonding pairs would occupy the remaining 4 positions. Hence, in this way, this geometry would give a seesaw geometry. And the axial and equatorial sulfur-fluorine bonds are slightly bent back away from the non-bonding electron region, suggesting that the bonding electrons or the bonding electron pairs are pushed by the non-bonding regions which is larger and greater repulsion. Hence, its bond angle is slightly altered as compared to the ideal value of the bond angle in the case of Ab5 system. Thank you for watching the lecture. Allah Hafiz.